Hello and welcome back to my channel. My name is Piyush. This is day 47 in the CK 2025 series. In this video, we'll be doing a deep dive into Gateway API, which is a newer form of Ingress, as you can call it in Kubernetes. So we'll be going through all those details. We'll be doing demo, and like always there'll be an assignment at the end, and the assignment details will also be provided in the GitHub repository along with the solution, like always. So let me just share my screen and let me just walk you through what we're going to do in this video. Okay, so we'll start with understanding the Gateway API, like, because this video is all about Gateway API, so this is what we're going to understand first. We'll see the basic difference between Ingress and Gateway API, because Gateway API is nothing but a newer version of Ingress, and prerequisite is Ingress. So if you don't know about Ingress, if you are new to Ingress, make sure you go through day 33 of this series. It will be there in the playlist, or you can search in my channel. My friend Abhishek did that demo and the explanation. He brilliantly explained everything step by step. So make sure you go through that video to understand Ingress. And if you have already covered that, or if you already know about Ingress from any other resource, that's okay too. Then you can continue with this video. Okay. So we'll start with that, and then we'll look into Gateway API architecture, like how it is different from Ingress and what all the other components involved in this. We'll look into some basic features of it, and then we'll do an end-to-end demo of implementing the Gateway API in a lab environment. Okay, I'll walk you through all the steps. Okay, so let's start with understanding how it used to work with Ingress. Okay, so in Ingress, let's say a user initiate an HTTP or HTTPS request with the Ingress resource itself, which is managed by an Ingress controller, and then the request based on the rules, um, based on the settings in the Ingress itself, it will redirect to a particular service, such as, let's say, an audio service, a video service, and then that service, like how a service behaves, service will redirect the traffic to the backend pods. Okay, so this is the usual Ingress flow. Now it had some drawbacks, it had some limitations, such as it only supports host or path based routing or mapping, and it only support HTTP based routing, right? So like TCP, UDP, all other protocols are not supported, and there were some other limitations. The way it works in Gateway is you can create basically different routes, like TLS route, HTTP route, UDP, HTTPS route, all the compatible routes you can create. And those routes, based on the rules defined on those routes, so it will have certain rules. It based on those rules, the request will be then redirected to a particular service, and then those services are responsible for redirecting it to the responsible backends pods, like these over here, right? It also provides you advanced routing capabilities. Okay, like with the Ingress, it only supported HTTP based routing. Over here it provides HTTP, TCP, UDP, HTTPS, like it is compatible with all the routes. And it also supports header based and query based, method based routing. So it's over here written header, query, method based routing. It provides you various other routing capabilities. Along with that, it also provides canary rollout of the routing, like you can split your traffic. Let's say 80% traffic will go to the newer or the older version of the application, and the 20% of the traffic will be going to the newer version of the application. And you can slowly increase that rollout based on the feedback you get from the users, the new application users, and so on, right? So it supports that as well, and it's everything is inbuilt within Gateway API. You don't have to do some additional implementation. Now, um you might be wondering, if it is an advanced version of Ingress, why isn't it called Ingress 2.0 or new Ingress or anything that has Ingress in the name? The answer to that is, it we don't call it that because the implementation is totally different. You know, while Ingress was part of Kubernetes itself, it was baked into Kubernetes, so you don't have to do any additional installation. But this gateway API resource, it is actually extended by a custom resource. You know what exactly is a custom resource? So let's say in Kubernetes you have different resources, right? You have pods, you have deployment. So these are all the inbuilt Kubernetes resource. Ingress is also one of those. But then there are certain resources that user wants to create based on their requirement, right? So the name custom resource, so they can create a custom resource definition. Okay, I want my custom resource to be called, let's say, Piyush 101. Okay, I can do that. Based on the custom resource definition, I can create custom resources, right? So like you have, when you create a pod already has a definition created within Kubernetes, right? So let's say you create a pod, and this is based on the definition created by Kubernetes. Now, this definition defines what all fields and what all the mappings that pod have. Like it has a kind, it has an API version, it has spec, metadata. In metadata, it has labels, name. Then in spec, it has container image, container name, and so on. So all these are defined in the definition of the pod resource. Now you can do the same with the help of a custom resource. You create custom resource as a part of different video. I'm just giving you a brief introduction if you don't know about it. But basically, you have a custom resource, and then it is based on a custom resource definition, right? The benefits of using a custom resource is you can add a lot of functionalities to it because you are extending the capabilities of Kubernetes API, right? This is how you can extend the capabilities of Kubernetes API with the help of custom resource. Now, um, as I've as I was explaining earlier, Gateway API is implemented differently than Ingress. Ingress was part of Kubernetes, but Gateway API is provided or distributed as a custom resource. These are the different, there are different implementation of Gateway API provided by different vendors such as Kong, Nginx, Istio, and so on. There are many others as well. The other difference is in Ingress, whenever we have to do something like routing, or when we have to do, let's say, a TLS redirect, we have to add annotations in the Ingress, right? It is done by adding annotations, but these annotations are not standard, right? If you are using Kong, it will be different annotation. If you are using Nginx, it will be a different annotation. So that means these annotations are implementation specific. The type of Ingress resource or the type of Ingress you are using, based on that, you have to use the annotation. So there is no standard way to write the YAML for it. Like it will be different for every other implementation. So it will be difficult to migrate between these resources. So this particular gateway API resource, it also provides you flexibility in that, like everything including your TLS redirect, request and response manipulation, traffic splitting, and different routing such as header, query, method based, all of these will be baked inside a new resource which is called HTTP route. Okay, so basically this is what we've discussed over here, right? um, you get your request through a gateway, which is an implementation of gateway class. Well, we'll look into that shortly, right? And based on that, based on the HTTP route, or based on the routes that you have configured, it will redirect the traffic to the different services and backend, respectively. So this particular HTTP route is like, it fits over here in this diagram. Now, these all things, instead of adding them to Ingress, in fact, Ingress does not have a lot of these capabilities, right? It only had TLS redirect and I guess a rewrite path, uh, like few features, right? But gateway API provide all these features and everything you can configure inside the HTTP route. Now, because it is not part of annotation, it's not configured as an annotation, you can use the same for different same YAML for different implementations like Kong, Nginx, and so on. You just have to change the other fields such as their name, the gateway class, and so on, but you don't have to change the implementation of it within the YAML because there is no annotation for it, right? So that's how it works. Now let's have a look at the architecture of gateway class and the workflow. Okay, so we have different um, APIs for gateway. The main components are gateway class, gateway, and HTTP route. Okay, so what are all those? So there is this gateway class, which is a type of load balancing implementation. Okay, let's say you are using Nginx. So Nginx Fabrics is one of the popular gateway class. So this gateway class is Nginx or Nginx gateway. Now there is this resource gateway, which is the actual load balancer instance. Okay. So when we were using a service of type load balancer, it did not have a lot of capabilities. In fact, it did not have any capabilities of traffic routing and TLS redirect, header based or path based routing, or there were very limited capabilities, right? Only host based routing and few others. But then we were using Ingress. It provides you some more capabilities on top of a load balancer service, but still um, it lacked few of the features which is covered by gateway. Now this gateway over here is the actual load balancer instance which receives the incoming traffic from the client or from the outside world or from the outside Kubernetes cluster, and based on the HTTP route it does the mapping between request and sending it to the service. Okay, so you receive the request, an HTTP or HTTPS or TCP, whatever request, and then you receive it to the gateway. Gateway is nothing but an implementation of a gateway class, for example Nginx. And then based on the routes configured in the gateway resource, it will redirect the traffic to the service, and service has different backends like pod 1, pod 2, or pod 3, which is controlled by a deployment. So this is a typical architecture of a gateway class, or sorry, gateway API resource. Okay, and the next is, so it also focus on a layered based approach. Like in Ingress everything was managed and controlled by one single team because you have one Ingress object and everything resides in that Ingress object, right? There is an Ingress there is an Ingress controller as well, but it was just an implement. It just provides you the implementation for the Ingress resource, right? But in Gateway, it provides you a layered approach, which is also a role-oriented approach. In this, every component of Gateway API is controlled and managed by a separate team. The Gateway class is controlled and managed by infra team. Okay, such as like whichever infra team you have in your organization. Then we have gateway resource itself, which is managed by cluster operators or your Kubernetes admins. Then you have your routes such as HTTP route, TCP, UDP, and so on. So these routes are managed by your application team or your development teams, right? Now after this, so we have covered some basic, we have done some groundwork of understanding gateway API. Now we'll be doing a demo, and in this demo what we'll be doing, we'll be starting with installing the CRDs, because um, like if it was Ingress, we can just start using Ingress. We create the deployment, services, Ingress resource, Ingress controller, and so on. But then because it was part of Kubernetes, but this gateway API is distributed as a custom resource. So we have to first install the custom resource definitions. So gateway class, gateway HTTP route, reference grants and so on. So using these uh, custom resource definition, will be creating the custom resources. So gateway class custom resource will be created by gateway class CRD. It will be based on that and so on, right? Then we'll install nginx gateway and gateway class, and basically then we'll deploy a sample app. We'll create the gateway resource itself, and then we'll also configure http route to receive traffic on certain port and redirect it to a certain port based on an http route, and then we'll validate these changes. Okay, so I'll just keep my tab away and I'm gonna share my screen. Let me share the screen. I hope it is visible. Okay. Everything will be provided in the day 47 folder of the GitHub repo. I'm sure now you have access to the GitHub repo. It will be there in the description, and the repo is same for what we have been following since day one. Okay. And that there is a folder resources. Inside resources day 47 hyphen gateway API. Okay. So this is the solution. There'll be a task.md file when you will be watching this video. So make sure you follow the task.md file, not this one, because this is the solution, the entire solution. Okay. Now it has some prerequisite that you should have a Kubernetes cluster running. You can use Minikube client or any playground such as Play with Kubernetes, Code Cloud, or by any cloud provider. So I'm gonna use Code Cloud Playground because I've tested it. It works fine, but you can use anything. Okay. So let me just move it to a different screen over here. Did I move it? Okay. All right. So yeah, you can use the link in the GitHub repository, and I'll share the link in the description section as well. Now let's hit on continue learning. And these are free labs, by the way, so don't worry about it. I'm gonna go to Gateway API, which is a newer topic. Hit on Start Lab. This video and like lots of video these days, they you might feel they are little over the board when it comes to timing and everything, because I'm not editing these days. I'm just publishing the videos raw. Whatever errors we face, we'll fix it on the go. We'll do the live troubleshooting so that you can also understand how to do the troubleshooting. I'm not going to trim any part of it. Okay. So it has few questions. You can go through that, or I'm just gonna skip this question and go to task number 6, which is the actual hands-on task. But it's good, like, because I'm aware of these things. I'm not gonna go with the you know these MCQ based questions. I'm gonna move directly to the task that we'll be implementing. Okay. So the task is to basically create whatever we have discussed. So to use the gateway API, a controller is required. We'll install nginx gateway fabric as the controller. Okay, so let's install the controller first. And for that controller, we need to install the CRDs first. Okay, so okay, this is the gateway API resources and it has CRDs. So just copy it, and basically this is using the customize reference or whatever we call it, version 1.5.1, and it's going to apply that changes. Okay, so if you want to check what's inside that, you can go to this link. Let me just copy it, paste it over here. Oops, sorry. github.com nginx. Why it is not visible? Let me see. Okay, inside that config, okay, CRD, inside CRD gateway API. So this is based on like standard. So there is standard and an experimental, which is like an alpha release. It has a customization YAML. Customize tool is what we have also covered in one of the videos, so make sure you check that out. And it's basically using this resource, gateway API config CRD. So this is based on this particular repository which has some CRDs. So you can again check that out if you want. Let me just open it, and gateway API, and inside that config CRD, I believe that was it. And inside that there is another standard and customization. Which one it used? It used the default one over here. So this is what it's gonna do. Okay, it's gonna create a gateway class CRD, a gateway gRPC route, HTTP route, reference grant. It will not be testing gRPC route or reference grant, but it's part of the customization YAML, so it will be installed anyways. So this is what we're going to do first. So let's copy this command and execute it. Okay, now you will see it installed different resources over here. Okay, and you can verify it by running kubectl get crd, and let's do a grep on gateway. Okay, you will see all these crds have been created. Okay, whatever we just saw. Now deploy the nginx gateway fabric crd. Okay, let's copy this. There is a crd.yaml. It will install crds based on the implementation of nginx gateway fabric. Okay, so let's paste it over here, and you see it also installs some more crds. Okay, and now to check what's been um, installed, you can do a grep on, let's say, which is the, let's do a grep on nginx. Okay, so client setting policies, nginx gateway, nginx proxies, and so on. So this, these all crds are specific to this nginx gateway fabric. Now we deploy the nginx gateway fabric. So there is a deploy yaml. Okay, so we'll do that, copy and paste it over here. Now you can verify the deployment. What it did, it actually, there is a deploy YAML which has a lot of resources. What are these resources? It will create a namespace, a service account, cluster role binding, config map. There is a service, nginx gateway, deployment, and most of these resources will be created in this namespace nginx gateway. Okay, so it created a lot of dependent resources for you to um, start using nginx gateway, right? So you can verify the deployment by running get pods on the namespace nginx gateway. Okay, it says the deployment is running. This is the deployment of nginx gateway. It has two pods, both are running. Okay, you can verify the service as well. Let me clear the screen. And basically service is get service on the same namespace. Okay, now there are two ports exposed. One is HTTP port on node port 32308 and HTTPS port. We're gonna change this port to something that is accessible in the sandbox environment. Okay, so this is a service of type node port, as you can see. Now run this command to update the ports from these to 30080 and 30081. Now, why we are doing this? It's probably because of the sandbox environment that we are using. Only these ports are exposed. Maybe that's the reason. Okay, so we have done that patching. Okay, and let's hit check. So this task is complete. Now we'll move ahead with the further task. Till now, what we have done, we have created, we have installed the crds of nginx gateway, crds of gateway api, and we have installed nginx gateway resource itself, and we have exposed it to a service as well. Okay, let's hit next. And now what we have to do, we have to create a gateway resource. Okay, now we'll be creating a gateway resource, and we'll configure it with the listener which has some routes and so on, right? So to do that, let's open the Kubernetes documentation. Okay, search for gateway API. Okay, the first link. Now, to create a gateway resource, which is this one, we need to also create a gateway class. Okay, let's see if the gateway class is already there. kubectl get gc. Okay, yeah, gateway class or gc, it will be appear over there. So this gateway class uses a controller, gateway.nginx.org, nginx gateway controller. It's already there, but if it's not created, basically this is the YAML using which you can create the gateway class. It's pretty simple, pretty straightforward. It says API version, kind, metadata, which has a name, and then in spec field we just have one field, which is the controller name. Okay, over here we are using the nginx controller, and this is the name of the controller, because gateway class is an implementation of a gateway controller. Okay, we are using gateway controller. Now using this controller, will be creating a gateway resource. Okay, which is the ask in this task. Okay, now to create a gateway resource, this is the YAML. So let's copy it and then we'll make the changes accordingly. So vi gc.yaml, oh, not gc, it should be gateway, but let it be. Okay, just the name. So API version kind is good, kind is gateway. Now metadata name is nginx gateway. So let's change this. Okay. Okay, and then gateway class name is nginx, should be nginx. Now listener is HTTP protocol, and then we have another field called allowed routes. Okay, so allowed routes inside the listener over here. Let me check as well. Yeah, on the same level over here. Okay, we add another field called allowed routes. That means, because it's like what all the routes are allowed and from which namespace and so on, right? So all those details can go over here, but this is optional detail. Okay, this is part of listener. Okay, allowed route and namespaces, and we provide from all. If we don't add it, the default is same, right? It means from same. What is same? Same means only the resources created in the same namespace as the gateway objects should have access to it, right? But we are configuring all. That means the deployments or services created it under other namespaces will also have access to it. Okay, so let's save this and let's apply the change. Apply -f gc.yaml. It says it's created. Now let's do kubectl get gateway. Okay, it says nginx gateway based on the class which is nginx, and it's created, right? Check. Okay, it says nginx gateway not deployed. Maybe we did something. Okay, I think I know what the issue is. Let's open the YAML again. Yeah. Okay, over here it says it should be created in the namespace nginx gateway. Okay, we have not added the namespace, so let's do that. Namespace. Okay, let's save again and let's apply the changes again. Okay, now let's do get. Oh, it should be in the namespace nginx gateway. Okay, because there is already programmed, that means it did not delete it and created it, it just created another one. Okay, so let me delete this kubectl delete gateway nginx gateway, and for the default namespace. Now if I do get gateway, nothing is there. If I do get gateway on the nginx, yeah, it's created and it's programmed. Okay, now hit check. Okay, this is done now. Now the next part and the final part is to create the HTTP route. Okay, it says the new pod front-end app and a service has been created in the default namespace. Now clear the screen. Let's check the service, get pods. Okay, there is a front-end app and we can just do kubectl get pods hyphen o YAML to check the YAML. What exactly is this pod doing? Okay, so go up. There is a lot of metadata. What we are focusing on is the image. Okay, so it uses a code cloud image which says web app color is the name of the image, and it's exposed the container on port 8080. Okay, and let's check the service as well. kubectl get svc on the default namespace. So front end service kubectl describe svc. Okay, so this service expose that pod on port 80. Okay, so it basically does the mapping, and it is of type, let's see the type, cluster ip. Yeah, it is of type cluster ip. Okay, okay, now the like it has been created, but if you are testing out it somewhere else, then you can create the similar pod, similar service in your environment. It's pretty basic, pretty simple, like what we have done earlier. Or you can just use a simple nginx pod. Okay, just use the nginx latest image and expose it uh, on container port 8080, then expose it with the help of a service on port 80 of type cluster IP. Okay, now it says expose the service on the path slash path, create the HTTP route name front end route. Okay, so HTTP route details will also be there. Okay, in the same document page, let's copy this and we'll make the changes. Let's do a vi on http.yaml. Okay, now the HTTP route name should be front end route. So I'm gonna go to line number 4 and then I'm gonna make the changes. Okay, now API version is good, kind is HTTP route, parent reference is name example gateway. Okay, over here we have to provide a gateway name which is nginx gateway. Delete the host name because we don't have any host name. Now rules matches path, um, type is path prefix, and value is slash because it says uh, expose the service on slash path by utilizing this. Okay, and then backend reference is the service name. So the service is front end app, front end apps app. Okay, so let me check. Front end app and then path prefix nginx gateway. Okay, we forget one thing, which is the namespace over here. So namespace, we have created everything in the nginx gateway namespace, so this is what we're gonna use. And then over here is port 80 because we have exposed the service on port 80. 8080 was the container port. Okay, so this looks good. Now what it will do, it will receive the incoming traffic on slash on this slash path. Okay, and then it will redirect it to the backend front end app on port 80. So this is based on the rules that we match over here, and it's a separate object which is managed by a separate team. Okay, so let's apply kubectl apply hyphen f http yaml. Okay, it says route created. Now we can just verify kubectl get http route. I believe this is the resource. Okay, not in this namespace. Let's do hyphen a for all the namespaces. Okay, it says front end route. If I describe this, kubectl describe http route name is this, hyphen n is nginx gateway, which is the namespace name. Okay, it says backend not found. Maybe it says route is accepted, but backend not found. Maybe we did some mistake in the backend reference. So let's do a vi again. Backend name is frontend app. Let's see. kubectl get svc. front end svc. Okay, so there is this mistake. Instead of front end app, it should be front end svc. Let's make the changes, save the file, and let's apply the yaml once again. Okay, configured, and let's do a describe again. Still backend not found. Da, 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 da. Maybe that was the last status. Okay, I believe, yeah, it still shows the message front end svc not found. Why? Um, front end svc is get service. Okay, let's see. HTTP route, front end route, nginx key. Oh, namespace is default. We need to create it in the default namespace. Okay, nginx, and parent reference is nginx, or like, yeah, it doesn't matter, but here we have to provide the reference. Okay, so the namespace of http route doesn't matter, I believe, but over here in the parent reference of nginx gateway we have to provide the reference. Now it should know like where does this object nginx gateway exist, otherwise it won't be able to find it and won't be able to do the mapping, right? So I believe that was the mistake. Let's apply this. Sorry. Okay, and let's do a describe again. Okay, it still says backend not found. Why? We need to find out. In fact, front end svc backend not found. Get svc, front end svc, and vi front end route. That's good. Nginx gateway is the name of the, was it? Let's see. Kubectl get gateway hyphen all. So nginx gateway was the name, and nginx gateway was the namespace name. So this is correct. Over here parent reference is correct. Now rules is match the path, which is path prefix, value is slash, and backend reference is frontend svc port 80. Maybe we'll just delete it and create it again. Let's see. Kubectl delete hyphen f http route, and then apply this again. Okay, let's do a describe again. Oh, it still says backend not found. Kubectl get pods. Okay, front end app is there. Get service, front end service is also there. Expose on port 80, and okay, front end svc port 80. Okay, and then path prefix slash parent reference is nginx gateway. Okay, okay, let's see if we are able to access the service or not. Okay, so kubectl get gateway and all. Okay, it looks it's there. So let's try to the service port that we use for HTTP was 30080. So let's try to open the service on the port 30080. No, it's not accessible. So something is not right. Okay, kubectl get svc. Um, kubectl get svc hyphen a, which is your nginx gateway, which should expose on port 30080, and this front end service is cluster IP. Okay. Um, let's do some troubleshooting. What can we check? We have checked the gateway. Okay, kubectl describe. We did check that. Or no, we have not checked that. Actually, we checked the gate HTTP route only. So this is the HTTP route. Now let's do a kubectl describe gateway, nginx gateway, and hyphen n nginx gateway. Okay. So it says status is false. Okay. So issues with the nginx gateway itself. Listener is programmed, accepted. Two routes are attached. Why? Okay, so there is the gr. Okay, no, that's the supported one. So there is, it says gateway is accepted. Okay, this is our HTTP route. Oh, this is the listener, which says from all port 80 and so on. Okay. If I do get on this, okay. Now let's check the logs as well. Logs of the nginx gateway deployment. kubectl get deployment hyphen a. So let's check this one. kubectl logs um deploy slash nginx gateway hyphen n is nginx gateway. Okay. Um, yeah, it does not show any error. These are just the messages, like the info messages, starting server, bind address, attempted to acquire a leader, that's done, starting job. Yeah, I don't see any errors over here. So this is okay. And then we can check the endpoints as well. kubectl get endpoints. So service has endpoint as well, which is probably the pod. kubectl get pod hyphen o wide. So 172.17.05, which is the same one. Okay. What am I doing wrong? Okay. Let's see. Let's do a check over here. Yeah, it says front end route created. So HTTP route is fine, but the service is not exposed. Service is not exposed. So kubectl get svc, which is, so this is the internal service, get svc hyphen a. Nginx gateway, which is a node port service on port 300. Let's do a describe on this again. kubectl describe svc nginx gateway, and hyphen n is also nginx gateway. Okay, now it says Oh, no, no, no. That's correct. Yeah. Node port on HTTP 30080 and node port on HTTPS 30081. So this is 80 and this is 443 on the same type node port. Yeah, I don't see any issues in this one as well. Mm, 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 mm. Okay, if kubectl get gateway hyphen all. Okay, this gateway does not have an address. Maybe we did something with the gateway resource itself. Okay, so let's check the gateway one more time via gc.yaml. Okay, so kind gateway metadata is nginx gateway, namespace is nginx gateway, gateway class name is nginx, listener http, and then port 80, protocol https, allowed routes namespaces from all. Okay, let's check if the gateway class name is nginx. kubectl get gateway class. Yeah, it is also nginx. Okay. Or maybe because we recreated and deleted earlier, maybe something, it did not created the route. So let's delete this again and let's recreate this. kubectl delete f gc.yaml, kubectl apply hyphen f gc.yaml. Okay. Get gateway all, it still does not have the address. Da, 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 da. Mm, 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 mm. Let's check their gateway class implementation. kubectl get gc, which is nginx hyphen o yaml. Okay, and okay, gateway class, and it is based on gateway nginx controller. That's okay too. Okay. Something is definitely wrong with the gateway over here. I still have to figure out what's wrong. Gateway class name is nginx. We have listeners, which is http. Um, mm, 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 mm. They might have a solution over here as well. HTTP route. This one is correct. And if we go to the previous, can we go back to the previous question? I'm not sure. No. Okay, so our HTTP route is correct, I believe. Yeah, this is correct. And then it says parent reference name namespace. Section name is optional field, but let me see. Let's compare the HTTP. Okay, so we have backend reference, which is front end SVC on port 80. Rules matches path type path prefix value slash. Parent reference is name nginx gateway. Namespace is the same. Section name is HTTP, and rest all are also same. Okay, so let me try to add the section name and let's see if it makes any change. kubectl apply hyphen f http.yaml. Okay, and let's do gateway. And if I do a describe on gateway, oh, this is okay, not this one. kubectl get gateway. Okay, nginx gateway. So kubectl describe hyphen n. Okay, and describe gateway. Okay, now it says looks okay now. Was that the issue? Okay, let's check the port 30080. No, that was not the issue. Okay. So that issue was in HTTP route. kubectl get HTTP route. kubectl describe HTTP route. I'm sorry if you are losing patience. I have told you earlier as well. I'm gonna do the troubleshooting live while recording it. So I'm not gonna pause the recording no matter how much time it will take. If you are feeling restless, you can definitely skip over to the end and see the solution. But if you want to test it out yourself, that's even better. Or you can just um, skip for next few minutes and see the changes yourself. Okay, it says route is accepted, all references are resolved, and now it does not show the error like what we were getting earlier of backend not found, right? It is able to match the backend. Okay. Um, so if it is able to do that, we should be able to see. Let's see, kubectl. We need to get the node IP. Okay, so get nodes hyphen o wide. Our node IP is this one, and if I do a curl on this, wait, curl on the node IP colon 30080. Oh, it won't be from here because we have to do the port forwarding. So 30080 phi on the slash path. No, yeah, it still says is the service exposed. Maybe there is some other issue. Now this is done. Now if I do kubectl get gateway, there is some other issue with the gateway as well. Maybe because it does not have an address. It should have an address, I believe. So do we have a gateway? Okay, let's see gateway. Nginx gateway. Maybe should I delete it and create it again? Kubectl delete hyphen f, or did that already? I don't even remember that. Apply hyphen f. And anyways, let's do that. No, 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 no. Okay, the front end route is fine, and viewport 30081. Oh, we don't have an HTTPS route, so definitely it's gonna throw the error 30080. This is where our service is exposed on. So kubectl get svc hyphen a 30080 on not port this curl 30080. Nope. Okay, let me check the steps one by one. We installed the Nginx, we installed um let's check the deployment as well. Get pods, they both are running. Okay, and then let's check the service. Okay, it's fine on port 30080 and 30081. Now it should have the node port value, which is there, cluster IP, and we have a gateway class, kubectl get gateway class. Gateway class is based on the controller gateway.nginx.org, nginx gateway controller, and the name is nginx. That's okay too. Now the nginx gateway, so kubectl get gateway hyphen a. Okay, and it was created at nginx gateway namespace. Name is nginx gateway. Gateway class name is nginx. Listeners are okay. Let's open this kubectl describe gateway, and we need to provide the namespace name as well. Okay, says gateway is programmed, but if I do get gateway and let's see, nginx gateway nginx gateway class, that is also accepted. Okay, now let's check the route. Maybe it's because I've created it and deleted, because I've created it in the default namespace earlier, gave the reference incorrect earlier, and that's why it's still not taking it somehow. Front end route namespace default What if I create this as well in the same namespace? Nginx Gateway. Kubectl apply hyphen f http.yaml get http route. So let's do check. Nope. ctl describe http route name is this. All references are resolved. The route is accepted. Okay, and let's check the logs one more time. Nope, nothing over here. Service also have endpoints, so that's also not the issue. Front end service input. Oh wait. Oh yes. Correct. It's the pod IP and pod. Okay. Okay. Let's see if the documentation says anything. Oh, it does not have a lot of details actually. Backend reference over here was on 8080. We did that on port 80. Gateway listener is on port 80. The backend reference on port 80. Okay. Can I go back to the previous question? Okay, maybe I messed up something. So let me try to restart this lab. Okay, let me try to do that. Uh, Let me try to do that really fast so that you don't have to overdo all the things. I have all the commands written in the GitHub repository, so I'm just gonna do a quick copy paste of everything. Okay, so let's copy this. Okay, let's go to question number 6, and this time I make sure that gateway is created properly without skipping to the next question. Okay, so I'm gonna start with installing Gateway API resource. Okay, this is done. This is there. Then install Gateway Fabric CRDs. This is done. Install Nginx Gateway Fabric. Install. Verify the deployment. Pod initializing. Maybe I was too fast. Okay, running. View the service. Okay, patch the service on the port. Check. Okay, this is done. Did we create yeah, let's go next. Okay, create the Nginx gateway resource. So I'm gonna copy it from the YAML that I have. Okay, let's compare it with their solution as well. So I'm gonna paste gateway.yaml. Okay, this is what I've copied from my GitHub, and this is what they have. This is correct. Gateway class name Nginx. Listener is HTTP port 80, protocol HTTP, allowed routes, namespaces from all. Okay, this is basically the same. kubectl apply -f g.yaml. It says configured kubectl get gateway -a. Address is still not there. I'm not sure if it has to be there or no. Okay, this is the same one. Check. Let's move on to next, which is HTTP route. So again, I'm gonna do the same thing. I'm gonna copy the HTTP route that I have in my GitHub repo. So vi http.yaml. Okay, and let's go over here and let's compare HTTP route front end service namespace is default. Nginx let's add the section name to make it exactly same as given. Section name HTTP rules matches path prefix 80 front end service port 80. Okay, if it doesn't work, then maybe the issue is with their lab only. Let me see. Yep, kubectl. Okay, now let's do get. Okay, it says route accepted and get route. Okay, and let's check. Oh, it worked this time. I did exactly the same like what I did last time, but I don't know what the issue was. Maybe I was missing something. So if you have followed the video till here, you might have already understood the issue. You might have already found it. So let me know in the comment what I was missing earlier. And let's check if it is accessible. Yeah, now I can see a blue app is accessible and says hello from front end app. Accessible on port 30080. I compared each and everything line by line, and still I think I was missing something. Or maybe because the way I created earlier, I created with this field over here. I created in the I gave this parent reference as wrong, right? I gave it section name. Yeah, this field was not there earlier. Then I added again, I reconfigured it. Maybe that route was not propagated properly, or it maybe takes some time to get the route propagated. Maybe it's documented somewhere in the documentation. I'm not really sure. It doesn't say anything. How about over here? Yeah, maybe. Yeah, I'll go through it later on, and maybe you should also. I mean, you might have been already able to figure it out. So I'll just leave. There's no point of dragging this video. We were able to complete the assignment. We were able to complete the task. If you were following, if you were learning this for the from the exam perspective, then this should be sufficient. This should be more than enough. If you want to learn more about Gateway API, then you can follow the documentation, Kubernetes documentation, and it has some additional steps of. Oh, no, that page definitely don't have it, but you can learn more about some advanced routing, some header based routing, or the traffic splitting part of it, and try to do some advanced routing with this gateway resource. So yeah, that's it for this video. It was a long video and it's pretty late. It's, I believe, 2 a.m. for me, or it's 2:30 a.m. My wife's gonna kill me. I'm gonna go and have some good night sleep. I will see you soon with the next video. And the next video will be looking into how do we migrate from Ingress to Gateway API, which is also one of the important question in the CK exam. So thank you so much for watching. I wish you have a good day, good night, whenever you're watching, and I'll see you soon. Thank you.